Hey guys, today's video is about logistic regression. Logistic regression is a classification algorithm which predicts the probability of a discrete outcome and makes the classification based on the probability it predicts. So indeed, logistic regression predicts a number, so it's called regression. However, it aims to make the classification. So in other words, we have to have discrete labels. So first, we need to import the package we need to use, and then we can create or import data. So in this case, say we want to predict whether a student will pass the exam based on the hours of study, and we can just copy and paste some sample data here. So we have two columns, hours of study and passing the exam. So hours of study is our independent variable, and passing exam is a binary target variable. There are only two outcomes. You can either pass the exam or fail. And in this example, 0 means fail and 1 means pass. And before we do further analysis, we have to convert our dictionary to a data frame because it's a common form for us to manipulate the data. So this is a function in pandas library, and you can see the first few rows of the data. So yeah, we have two columns, hours of study and passing, and we'll use these two columns to make logistic regression model. So next, we can see our data by plotting a scatter plot. But this step is optional. You don't necessarily have to visualize the data because it's often not feasible because we typically have multi-dimensional data instead of like one-dimensional here. But anyway, we can still visualize the data in this case. So when you use scatter function, you have to put the x and y, which is the variable on the x-axis and the variable on the y-axis. And by convention, we just put independent variable on x-axis and target variable on y-axis. And this is the x-tick, it's just the marks on x-axis. And we use 0 to 50 because the minimum of hours of study is 1 and the maximum is 47. So this range indeed includes all the possible values. And this is just the label and title of our graph. So as you can see, we have this scatter plot. And students who study less, like here in this region, tends to fail the exam because they have 0 in this target variable. And students who study more tend to pass the exam like here. However, in this middle area, like when you study between like 15 to 25, the graph is kind of messy. Some students pass the exam where others did not. So this will we can expect our model would not perform well in this area because it's confusing, it's not deterministic, but we just go ahead and see how our model goes. So before we build a model, we have to split our data into training and testing. I hope you all understand the training data can only be used in the training phase and testing data can only be used in the model evaluation. Otherwise, the evaluation of model will be biased because we kind of leak some information to the model if we just also use testing data in the training phase. So it's actually easy. We can use the function in Python, y_train y_test equal. So we can use this train test split function. And we first pass our independent variables and our dependent variables. And test size is 0.4 means 40% of data is used for testing. 60% is for training. So actually, we typically use 20% of data for testing, but because we don't have that much data here, so we just use 40%, but you can tune this number as you wish. And we can assign a random state, and this can be any number. It just, when we assign a random state, the splits will always be the same. So if you specify the same random state as me, you should get the exact same split. Oh, it's really messy. Okay, so then we can create our logistic regression model. Before we do so, we have to convert our training data to the shape the model requires. So we use reshape. This means -1 means we'll shape the data into whatever size, but with 1 columns, because we specify here. So the algorithm, the function will figure out which size is appropriate for this array. So this is figured out by reshape function. And then after we reshape the data, we can build and fit the model. So it's logistic equals to logistic regression. And you can see there are kind of a lot of hyperparameters you can tune here. But for simplicity, we will just leave them as default. And then we can fit our model using the training data we just transform. Fit. Train array white chain. So to specify this further, the fit function expects the training array to be the shape of number of rows and number of features. So because this is essentially 1 feature, hours of study, so we specify 1 here. Okay. So this is actually how we build and fit a model. We now have a trained model. Now we can evaluate our model testing set. We have actually a lot of performance measures, but we'll talk about 3 here. First is accuracy. You just use model.store, and but you have to convert the testing array here, because as previous, the model expects the array to be of shape and rows and features. So xtest array equals to xtest. So this will work. And back to our function, we put our independent variables and our target variables. Because we put our target variables here, so the model or the function can compare the predicted values with the actual values. So it's 0.83, and we'll explain how to interpret this values data. And then we can look at precision. So it's precision score, again, xtest array, y-test. So hold on. Oh, sorry. We have to pass the prediction. It doesn't predict for us. So yeah, this will work. So essentially, we use the model to predict the probabilities or the classification results. So to clarify, we can see here, it's actually the labels, but you have another function called predict proba. This is the probabilities of a data point belong to class 0 or belong to class 1. So in this case, the first example should belong to class 1 because it has higher probability. In other words, the student is predicted to pass the exam. So yeah, the first data is predicted to be 1. Okay, then we have the third measure called recall. So it's kind of similar to this one. We have recall score is 1. So now we can interpret our model evaluation measures. So first we start with accuracy. I'll just use the rule. Accuracy is the proportion of data correctly classified. So this means our accuracy is 0.83. So we have 83% of data that are correctly classified in this testing set. So we can actually visualize the results using the scatter plot again. So I just copy and paste some code I wrote before. It's recalled and predict equals to model.predict. Okay, so you can see this is our testing data. We don't have many because the data set is essentially small, but you can see the incorrect tuples is right in the middle as we expect before, because like in this region, some students passed the exam while the others did not. So the model will be confused if you study like 15 to 25 hours. And indeed, the incorrect predicted data point is located in this region, like 25. So next we can see the recall. Recall is the proportion of actual positives that are identified correctly. So the recall score is 1, means all the actual positive data are correctly predicted. It means all our data that all the students who pass the exam are classified as passing. And then precision is the percentage of predicted positives that are actually positive. So the precision is 0.71, means 71% of students who are predicted as passing the exam actually pass. So it's not perfect, as you can see here. These are the predicted positive data, and there are 2 incorrect data points. So it's only 71% of precision. So you should always look at these measures instead of just look at one, because it's kind of like misleading. Sometimes we might have high accuracy but low recall or precision. And then we can look at coefficients. Coefficient can tell you the relationship between independent target variables. So you just type model coef. So in this case, we only have one coefficient because we only have one independent variables. But if you have multi-dimensional data, you will have many coefficients. And we typically use the sign to analyze the relationship. So in this example, the coefficient of hours of study is 0.21, means the hours of study is positively correlated with passing the exam. In other words, if a student studies more, he or she tends to pass the exam. However, if a student studies less, he or she tends to fail the exam. So it's kind of intuitive and it meets our expectation. However, you don't interpret this number as when a student studies 1 more hour, he or she has 21% more chance to pass the exam. It's not how we interpret the coefficient in logistic logistic regression. It's how we interpret the coefficient in linear regression, and it's kind of the different concepts you need to distinguish. That's pretty much it. Thank you for watching today's video, and I hope you understand logistic regression more.